Layered Insight is the industry's first embedded security approach for containers. Trusted by Global 1000 enterprises to secure their containerized applications, it's the only solution that requires no root privileges, has zero dependency on the underlying infrastructure, and is fully portable across any container environment. Unify DevOps and SecOps, enabling the rapid development of containerized applications without worrying about security. To learn more, please visit layeredinsight.com/ASW. Rapid7 powers the practice of SecOps. Using shared data, analytics, and automated workflows, SecOps unites IT, DevOps, and security teams to make security an outcome of innovation. Rapid7 combines technology, expertise, and advocacy to drive vulnerability management, application security, incident detection, and log management for more than 7,000 organizations worldwide. Power up your SecOps practice with a free trial at rapid7.com/securityweekly. Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW.
Welcome back, everyone, to Application Security Weekly. This is the news for the week of April 30th. So, Paul, first and foremost, you probably caught this in the news. SEC fines Yahoo with $35 million for not reporting cyber breach. Man, that's a lot of money, huh?
Yeah, Yahoo's, I think a shining example of how a breach can impact an organization. Certainly, it affected their acquisition, which, did that even happen? I'm not sure. So Yahoo did get
billion.
Okay, so it certainly affected their acquisition, likely because they knew that they were going to get hit with fines as well, and here it is with a fine. So
the interesting thing I think about that acquisition, though, Paul, was that when Verizon bought Yahoo, they basically made them sign that none of the properties that were purchased by Verizon would be liable for any following fines or lawsuits that Yahoo would incur. So basically, they protected themselves legally by saying, yeah, we will buy all this from you, but we are certainly not paying any fines for the mistakes that you made in the past.
Right.
Which I thought was pretty smart of them, given that,
Yes.
they
knew this was coming.
Yeah, this is definitely a matter of time. The other thing that I thought was interesting here as well was that in this case, they actually cite in the article that, of course, companies take months, sometimes years to disclose a suspected breach if they do at all, which, seems kind of normal. But what I find is, in this case, Equifax, key example here, waited, several months at this point for 143 million people's data that was breached on their system to finally report it. So I imagine we'll see something come down pretty heavily on them I'm forgetting now, but I feel like we're going to see more happen there from the SEC as well. So this is one of those situations, though, Paul, that I think it's kind of a dangerous situation for security professionals to be in, because we are the ones that learn about and know about the breaches before anyone else in the organization. And if you happen to work for an organization that has stock that's publicly traded, you have to start, being real thoughtful and careful about, can I actually trade my own shares in the company, or do I have to give this over to a trust or a third party at this point, because I know where we're vulnerable or that we've been breached. I just can't foresee this being a good position to be in as a security professional going forward. And in this case, I'm not a financial advisor and I don't pretend to be one on this podcast. But to that end, I imagine that people that work in security, if you do have shares from your organization, you might want to think about talking to a financial advisor about this, because I can imagine that this is going to get worse before it gets better. What do you think, Paul?
Well, and I also think the other thing is, it's hard to know what a breach will cost and what the fines will be versus how much it's going to cost to fix it. And I know many organizations don't think in those terms, because they're like, well, a breach hasn't happened and it probably won't happen, so I'll take that risk. But do they really understand everything that's playing into that? And is it cheaper to fix the issues than pay what it's going to cost to pay the fines and then fix the breach? And we talked about on Paul Security Weekly last week about Atlanta and Equifax, actually, the hundreds of millions of dollars respectively that they're spending on the cleanup of the breach. And would it have been cheaper? Certainly better from a PR perspective, but maybe cheaper to just fix those issues.
The irony here, I think, is that I believe, if I'm not mistaken, the breach that affected Yahoo was actually based on functionality that they themselves put in to their software.
Hmm.
Um, so in this case, it's almost like a situation of they literally opened the back door to the Russians that ultimately led to the breach in the first place. So to that end, it's almost a double whammy, right? Like they get hit with the breach, plus all of the fallout of dealing with the breach, plus the fines on top of that for functionality that they put in. It's not even like it was just bad software. They put this there, which I don't know. That's just like everything bad about that just is just one pile of a dumpster on fire. And I'm pretty sure that's probably why people like Alex Stamos left, because they realized that the upper management was accepting risks, or even in this case, making decisions to incur risk
Right.
without properly vetting that information.
Hmm.
So that is just troublesome in and of itself. The other one that I wanted to talk about here, Paul, and I think that we talked about it briefly last week, and I know that you talked about it on Security Weekly, which is the hackers built a master key for millions of hotel rooms. So last week in an Application Security Weekly, we mentioned this because it was hard to update the firmware for each and every lock inside of a hotel. But the thing that I found interesting about this was that it took the researchers from F-Secure something like a decade to actually figure this out. So it's a problem of both two things. First of all, being able to update all of these devices, and the second thing is when these devices were built, the technical inflation in this case that they weren't anticipating or updating for. So I feel like this is a story of they didn't do the things right for failing to build update mechanisms, and then they also didn't think about the incurred technical inflation that they were now taking on by thinking that no one would ever be able to do this. Any thoughts on this story, Paul, since you've probably talked about it a few times now?
We did theorize that there was software that allows each hotel to program all of the hotel key cards that comes from this manufacturer, and that a lot of the flaws likely were uncovered or discovered as a result of reverse engineering this software. I don't know if that's really the case, but one could easily theorize that, right? Like there has to be some kind of software component. And the way they described the attack was that if you got a key card from a particular hotel, you could then read what's on that key card, derive what is the master key based on that, and make a new key. I theorize you could only do that with some knowledge of the software that's generating it and its master key. So they had to do some reverse engineering of that software, which brings me back to how you protect secrets in your software to prevent people
Right.
from gaining enough knowledge to understand how to essentially reverse engineer the process or discover the keys in your software. Those are secrets in your software, and how do you protect them was kind of my question for you in the light of this show being application focused, right?
And so part of this as well, Paul, so not to dodge the question entirely, but you would think that they have the ability to build a master key for an entire, brand of key cards, as opposed to having randomized master keys for each location, right? So there were probably ways to architect this, even where they were still failing to protect the secrets of their intellectual property as effectively as they should be, but at the same time, at least make it so that it's a localized attack as opposed to a global type of attack, right?
Yes. I think
So
it's an architecture issue. How do I construct a system that limits risk, knowing that someone and I think Jeff Mann talks about this when from his days working in crypto, like when he was talking about designing crypto, he's like, we designed it that everyone would have access to everything, and how do we protect it when it falls in the wrong hands? I think organizations today need to also take that into account and say, okay, what if someone has a key card? What if someone has a lock? And what if someone has our software? Then what? And I don't think they're in
right.
their threat modeling, they're considering that scenario, because a lot of these companies, ICS in particular,
Why would
like,
they
well,
ever have our key
yeah,
card?
why
Or
would
why would they
anyone ever?
have
And I
our
think we
lock?
saw this with the radio hacking with the emergency
Yes.
sirens too. It was kind of the same
Yep.
thing. Like, oh, well, we put this. Well, how would anyone have access to it? Well, no. Design your system knowing that if someone has access to all of these pieces, how do you protect your client and limit the attacks? Like you said, Keith, maybe we can limit it to just one hotel, or construct it so that it's much more resilient than it was. And I think that's really the lessons learned here when you're designing software and systems. Got to take security. When you look at security, understand what if someone has access to everything, then what?
And so it's funny because I think that on that same show that we were talking about, the sirens, was where I coined the term or the idea of technical inflation, which in
Yes.
my mind is different than technical debt, right? Technical debt is knowing that you are doing something that is perhaps not what you should be doing, but you're doing it because of, need to deliver to the customer, or speed, or not an entire or full understanding of what you're actually doing. Whereas technical inflation is the problem set of the future state that could occur that you have no way of planning, right? So nobody knew about software defined radio 10 or 15 years ago, right? That's
Mm-hmm.
something that's pretty new. And so to that end, as in the case with the radio stations, and as the case here with, NFC, or in this case, the RFC chips, or RFC mechanisms that go on these cards, right?
RFID. Yeah.
So RFID, thank you.
Hmm.
Thank you. I knew I was getting
I
it
knew what you
wrong. I was
meant.
like, RFC sounds wrong. Excuse me. So to that end, it's like, back then, when these were originally being made, no one even thought that an individual would be able to build the kind of technology to do this themselves, right? So that's the idea of technical inflation in place, where okay, nobody could, in theory anyway, do this other than the manufacturers of these devices,
Right.
and then now people can. So in a way, the way that they could have or should have really architected this is a fewfold. First, make the software installation for each location have some sort of unique identifier for the master keys for that location. Then, secondly, have an update mechanism in place for all of the devices that makes it easily able to update all of the devices within a wireless network, or within some sort of easy mechanism where you can quickly walk by and just update all of the firmware on them without any sort of finagling of the device in a meaningful or a deep way.
Well,
So,
and
and this,
that right there opens up security vulnerabilities too, because if you make it easy, then that means attackers could potentially gain access to it. So, yeah, I
right.
mean, we were talking about that, right? Because this isn't the first time we've covered hotel security in this light, right? There's always been I think they modified like a Sharpie or something that you can put in the USB port inside of the locks to also unlock the door. Was a previous attack that essentially accomplished very similar things to this. So it's certainly interesting.
And so to that end, it's build your tools to be able to update effectively, and think about the technical inflation that may occur, and pay it down in advance if you can. Because in this case, Paul, they have a central server for the software patching, but as we talked about last week on Application Security Weekly, the firmware on each lock needs to be updated, which, as you and I both know, is not a trivial thing
Nope.
to do. So yeah, it's that technical inflation idea just keeps on bearing fruit, and this is just another situation of it. Uh, Speaking of which, I wanted to actually skip ahead a little bit, because in this case, Microsoft has done some very interesting things talking about technical inflation and technical debt, where they've quite literally dismantled their development group for Windows. By actually taking those development groups and splitting them up into two other properties. Now, a few weeks ago, Paul, I think we talked about, I'm forgetting which Microsoft product it was. It might have been the installed Microsoft Office, but I can't recall. This was on Paul's Security Weekly, and we were discussing why it took Microsoft so long to patch something. And I, at the time, said, well, it's because they want you to go to Azure, and they want you to go to Office 365, and they want you to go to the cloud. And here's quite literally a situation where a few weeks later, we find out from Satya Nadella, the CEO and founder, or not founder, excuse me, CEO of Microsoft, where quite literally he's dismantled the Windows development group and moved part of it to the Microsoft 365 experience, and the other part to the Azure team. What are your thoughts here, Paul? This is crazy to me.
I think it's some great analysis, Keith, that the reason why it took so long to fix things is because developers are moving around, and there's been some organizational changes that impacted Microsoft in a big way. I think that theory's sound. I mean, I don't know that we'll ever confirm that, but I think it's a good observation for sure.
Yeah, and in this case, it looks like all senior leadership is shifted around as well. So Windows, Office, and third-party applications and devices are being rolled into the Microsoft 365 experience. And then the Windows platform team is being rolled up under the Azure organization, probably because a lot of what they're going to be doing with Windows Server instances is going to be delivered through Azure in effect. So they're going to be tying in that cloud functionality with a lot of their future server implementations, would be my guess. The other interesting thing that came out of this article, though, is Microsoft is building an AI ethics in engineering and research committee called Aether. So they're actually now pushing pretty heavily into the AI side of things, which I thought was an interesting kind of tell inside of that letter. And then, of course, strategies and tools for addressing bias in AI was actually specifically called out, which I thought was pretty cool.
It's pretty interesting.
Because,
well, I think going back to your previous point too, if you've got some Microsoft Windows O-Day, you're likely going to be O-Day for maybe a little longer as these organizational changes kind of roll out, and they get back in the swing of things, which is kind of scary. I actually also believe that your story number 2 under "If you build it, they will come" is one of the most interesting developments that I've seen in IoT security in some time. And it's so much so that we're actually reaching out to Microsoft to find some folks who can talk about this a little more and share the knowledge, because this is really cool.
Yeah, this was incredible. So the few things that I took away from this that I thought were interesting is, first, Microsoft has developed a cloud technology they're calling Azure Sphere.
Yep.
And what it is it works with a very specific micro processor that is used in IoT devices that interacts with this custom version of Linux that they've put together to go with it. Because in this case, they found that Windows and any version of Windows that they would try to use was just too big. So Azure Sphere is combining to solve the problem of the hardware and the software and the cloud all at once, which helps companies build and maintain their systems in a simplified manner. Which, as we both know from what we were talking about just a few moments ago with the firmware on the locks, right? If you suddenly have a microprocessor with a very simplified controlled Linux environment that talks to a cloud instance that gives you easier management and maintainability, well, suddenly, if you're using this sort of infrastructure to manage and maintain your IoT devices, cool. You all your locks are, there's a master key that's now out there for all of your locks. 2 seconds later, you fixed it because now it's getting pushed out over Wi-Fi to these IoT devices through that cloud instance, and then the microprocessors can go ahead and just leverage that new bit of firmware, and you're good. So this was incredible to me, Paul. Any additional thoughts you want to add here?
Well, yeah, and I don't think it's going to wipe out all attacks against IoT devices. However, this to me has the potential to make it a lot more difficult to be able to do things like run rogue firmware, like completely replace the OS on these devices, because it's not going to have a code signing certificate or whatever other protections are built into the hardware. And that's the platform that the architecture that I was reading. I think it also has the potential that if I'm trying to run code or unauthorized code on these devices, it can probably put the kibosh on that as well. Exactly how it does that is why we want to get someone from Microsoft to help us with those. I've just briefly read one of their kind of press release things about the architecture, but if it can help us manage and control and validate the firmware update process when we send out new firmware to these devices, like those 3 things combined have the potential to really make a significant impact in the security of IoT devices. Those are all systemic and fundamental problems that we see today across the board with IoT devices, which is why they're being attacked so much, because they don't have any of those controls, which means I can replace firmware, I can run code of my choosing, I can bank on the fact that people aren't going to update because there's no automated update process. And who better to implement an automated update process than Microsoft? So for all those reasons, I think this represents some of the most exciting research and a project that can help us increase IoT security. But we'll see. I mean, that doesn't mean they're going to be impenetrable, right? But I think it has the potential to really raise the bar.
And to that end, I think that what it's going to do is, even if they are, something that can be compromised, right? To that end, what will end up happening is they can suddenly go ahead and actually be updated more rapidly, right? Like you can detect these problems quickly, and then you can update them quickly, which is huge. So the kind of a quote from the article is, the chip OS combo that they're using will be integrated with Azure Sphere Cloud Security Service, designed to keep the devices up to date with security patches for at least 10 years. I don't know any IoT device out there today that is supported for 10 years. That to me, that statement right there, I thought was really the most incredible part
Yeah.
is
I
that they're
mean,
going to be supporting this.
yeah, and support is a big word there, right? Deployment, sure, more than 10 years. Supported, that's
Right.
a different story. I also think that in terms of standards, if we could standardize the way that administration is done, both from the firmware side, but also from the end user side, how do I access the device? Is there some kind of web server component on that device? If we could standardize that, if we could remove backdoors from that process, if we could remove insecure web applications that are providing a management interface, that's another huge thing. I don't know that their architecture I've read so far addresses that issue, but it certainly could have the potential to have a more standardized framework for these devices. Ed Scott has talked about this on Paul Security Weekly years ago and said one of the issues is there's no standard as to how we manage, monitor, and maintain the IoT devices.
Yeah, and this will definitely change the game. In fact, this rolls really nicely into story number 4 under the "If you build it, they will come." And excuse me, actually, story number 3, I should say, which is the FDA is actually rolling out a digital health software pre-certification program. So, in this light, and kind of the idea of being able to update the software on devices, well, what other IoT device do you think could be more important than medical devices? So, what they're doing is they're looking at building basically a program where software as medical device products can be adapted to respond to glitches, adverse events, and other safety concerns quickly, where the FDA is working to establish a regulatory framework that is equally responsive when issues arise to help ensure that customers can continue to have access to safe and effective products. And Azure Sphere sounds like a great way to do that effectively, because now you have a way to say, okay, if all Azure Sphere is pre certified, then suddenly you now have the ability as a device maker to say, cool, if we use their chips and their
Right,
OS,
right.
we have the ability to update that firmware, that software, that whatever as we need to. And we're pre certified to do it, which is one of the biggest, I think, hurdles in the medical device manufacturing industry is once it's approved by the FDA. I've talked with Josh Corman about this a number of times, and he's probably going to listen to this and scream at his computer or his phone, which is there's a belief that once you've got approval by the FDA to deliver or ship a product, you can't go back and change it unless you want to get recertified. Now, I've been told that that's not the case, but I don't know under what regulations or what standards actually exist that show that to be the case or not. My understanding is nobody's really put that to the test because nobody wants to be the first person to get sued by the FDA or recalled by the FDA for doing it. So this is kind of nice to see that they're actually now addressing that.
It depends on how the FDA is defining that. So there are certain indicators they may say, under these conditions, you can continue or re-release this product or whatever into the marketplace without reseeking FDA approval. There's typically some triggers in there that say if you're changing something in this way, then that absolutely has to be approved. And then, there's people that kind of like cheat the system, right? No one wants to have to go recertify with the FDA. So they'll structure their product lines such that they continue to make those, maybe even make some changes in there, but still stay within the FDA guidelines. I have a lot of experience in looking at FDA regulations from my work in the cigar industry, which for years now has been dealing with what that looks like in terms of FDA certification, and learned a lot about that organization and the way they operate in current industries and a lot of the challenges and benefits that the FDA can present to any marketplace, right? Whether it be cigars or whether it be technology, two totally different industries, but a lot of the same themes are occurring. And so in the cigar example, right, you could have a particular blend of cigar, and this is still being debated, I believe. Like you have to define like what is in that blend. Well, like what if you change it, and what is a change? Like my crop is different every year. Does the fact that I have a new crop, like if I add some kind of new fertilizer to the soil, is that a change? Do I then have to go get recertified?
Oh, geez,
Certainly if I
yeah.
use a different plant, maybe I do, but like what's the trigger, right? And it's the same thing with embedded devices. Like what's the trigger? Like I'm on a new firmware version. Does that mean I change stuff that I have to go recertify? And what are those?
Right. Is
what
it
are
a
those
minor
rules?
version or a major version
Right.
change? Is it like a kernel change? Is it any number of things? Right. Is it a library change
Mm-hmm.
versus yeah. So that's
Those
a
are
huge
not
set of
easy
problems.
things to define, definitive. Like have a definitive answer for, right? So that's interesting.
And the hard part as well is that the FDA gives, some general kind of guidelines, but they don't give you like a strict framework, right? It's not like
Right.
PCI.
But that can be a good thing too, right? Because it gives the market some flexibility to allow more players to be in companies in the market. But it could also be a bad thing if they're not being strict enough. That means people could put a vulnerable device on the market more easily. So it's a balancing act between that control and security with the FDA. What I do think is a positive thing is we talked about Microsoft's Azure Sphere as a framework. Now we're talking about having some regulations that will help develop a standard for security, a minimum security for systems in the marketplace. I think those two things combined, right? Having the FDA or some governing body have some kind of standard, and also have a more detailed framework or guideline
An example
available,
of the standard in practice.
right, that you can use. So you say, well, if you use this, then you're in conformance with, and just having those two things, I think is a really good thing. The fact that we're talking about those two things in the light of IoT devices is very encouraging. Now, how it's implemented will, of course, determine the effectiveness, as with anything. But I think it's a positive thing that we're talking about having these two things: guidance from, regulations from the government, guidance and standards from other bodies like Microsoft. I think it's a really good thing. Could be.
Yeah,
Could be a good thing.
Right. We'll wait and see, I guess, right?
Mm-hmm.
Who knows? Maybe the firmware will be like the locks on those hotel doors, and then
Yep.
everything goes to hell at that point. One of the things that I did find interesting as just kind of a final thought on this, though, was that one of the things that they will allow for under this pre-certification program is the opportunity to collect and leverage real-world post-market data, which I thought was interesting because it allows for companies to go from being just life science providers of, an MRI machine or a pacemaker to actually being a digital life sciences company where they can now say, okay, based on your heart rhythm from your pacemaker, on average of this and your current heart rate, it looks like you're going into cardiac arrest, or you will be soon if you continue upon this path. And we can make sure we alert, say, the EMTs that are nearby of this early, right? So that could really save lives, which I think is incredible that they are actually allowing for that sort of kind of post-market gathering of data. And then, of course, there are probably some people screaming at at their phone right now saying, "What do you mean my privacy is being violated?" Which, I'm a bit of a privacy nut myself, so I can kind of see this going both ways. But I thought that was interesting as well.
I wanted to hold on. Catching and dealing with naughty devices on my home network. Story number 4 under "If you build it, they will come." They're using Pi-hole in this example, which was intended to be in a Raspberry Pi. My advice to our audience is you can install that anywhere. And my advice, if you're gonna do this level of DNS, don't do it on a device inside your network, because it's like one more device you have to manage and maintain inside your network and like keep power to and network and all that stuff. I took the Pi-hole project and I put it on DigitalOcean droplets, which are really cheap, and that's how I run them. So like it's off in the cloud. I have 2 of them. I don't notice there's no noticeable performance impact to doing that. So I like taking the Pi-hole project and putting it and putting your own DNS out in the cloud. That way you can have multiple locations that point at it. You can point for a mobile device. I think it's a lot more flexible. That was my advice for our audience there. And you can go back and watch a lot of technical segments about that on Paul's.
That's clever. No, I really actually like that idea. It's funny because when I moved into my new place, I've got a bunch of Ubiquity gear, just like Scott Helm here does in the article. And I was looking at this and I was like, cool. Like I've kind of retired my Raspberry Pi in the Pi-hole project, and I don't necessarily want to take it back out and put it in kind of the closet that I have for all my networking gear. But I never thought of putting it in the cloud. That's actually rather clever, Paul. I like that idea a lot. So So if people don't see me online for the next few days, it's because Paul messed up my DNS by convincing me to put it in the cloud.
Yeah, I have to go back and rebuild one of mine too. So yeah, it's pretty cool.
So just a couple of things I want to highlight at the very bottom under food for thought. I've included, in this case, not 1, not 2, but 4 cartoons from the Commit Strip webcomic, which I thoroughly love. They're British, and I think that that's just a fantastic webcomic. The last one being security, 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 which I think people will find funny. So with that, thank you everyone for joining us this week for another episode of Application Security Weekly. Remember to git commit and stay classy.